So in this case, we'll have flow on this side. We'll have yield on this side. And then as yield increases, so does our flow, and our actual yield looks something like that. Now, if we go back to the older Green Star monitors, where we're doing a high flow and a low flow, or what a lot of guys like to do is just the high flow, the one load calibration, you're actually running a calibration point somewhere along this graph. So say this is, for example, say this point right here is equivalent to 100 bushel corn. This point right here is equivalent to 200 bushel corn. This point right here is equivalent to 300 bushel corn. All right, as we move across that flow curve. So if we go out with our 1-point calibration in like an older Green Star 1, older Green Star 2 monitor, and we do our 1-point calibration, say at 180 bushel, what happens is this becomes a linear calibration. All right, it's only got 1 point. It's a straight set, and what it does is in this region right here, we are actually underestimating yield. In these regions right here, we're actually overestimating yield. All right. Our actual yield for the whole field, when it all totals it up, once it's overestimated so many times and underestimated so many times, actually becomes very, very accurate. All right. And a lot of guys have problems with that. They can get their combine within 1% or 0.5% of what the scales say, but their maps still do not carry spatial variability because they're overestimated in quite a few areas and underestimated in quite a few areas. It does not give us the map that we want. All right, if we run a high flow and a low flow, so what can happen here is we can run our high flow. And say we do it here. We run a high flow way up here, and we run our low flow. And now we actually set where these dots are. All right. Or in this case, we could run, say, our high flow point here and our low flow point here. Now we will actually, our curve looks something like this. So now we actually underestimate every single time. All right. Which is okay, because at the end of the season we can actually scale this whole line and move it that way. But because we consistently underestimate it every time, when we scale the line all one way, we actually become very, very accurate, and we keep that spatial variability, because that's the biggest thing that we want when our yield maps. We want to be able to see where these spots yielded and how they yielded compared to other spots within that whole field. All right. So that's the biggest thing. A lot of times guys don't want to run the low flow when they're doing a 2-load calibration, because it actually does make them less accurate. And it will, because now instead of overestimating and underestimating canceling each other out, we're always underestimating, or we're almost always overestimating, depending on where those points go. All right. So we definitely recommend you running your low flow compensation in those older Deere monitors, because of the increased precision that it provides. And then at the end of the year, we can scale it up or down to make it match your scale tickets. You'll end up with a lot better maps because of that. Now, on the ag leader monitor, we have that same graph. Only this time, we have that same graph. We're going to put multiple points in. So we actually want to pick calibration points that are along this point. So we actually try to hit a flow rate right there. We actually try to hit a flow rate right there. We try to hit a flow rate right there. All right, and they're simulating different yields. This is simulating 100 bushel. This is simulating 150 bushel yield. This is simulating 200. All right. So by simulating these different yields across the bottom and then weighing them, we provide truths along that line to try to create our own curve that mimics the actual curve as much as possible. So how do we do that? Well, if we could go into an area that yielded 100 bushel and take a load out of it, perfect. And we had an area that we know yielded 150, perfect, and an area that yielded 200, but we don't have that. So what we want to do, say in this scenario, we have a field that fairly consistently yields 150 bushel. All right, so we know this is our graph over here. These are our flows, say at 3 miles an hour. So we know at 3 miles an hour, we are going to create our 150 point. So now this is 3 miles an hour. But if we slow down to 2 miles an hour, the flow will drop. When the flow drops, the actual flow through the combine is going to mimic 100 miles an hour. All right? If we start speeding the combine up, say to 4 or 5 miles an hour, we actually get higher flows through the combine, and our curve starts to establish. So by combining 150 bushel corn and picking the right speeds, we can actually simulate all the way from 100 to 300 bushel corn that hopefully we may see at some point in some field throughout that season. But it's very imperative that we get these set correctly and that we pick nice even yielding spots. All right. And that's probably one of the things that definitely need to consider is when you're out there picking to calibrate, we want as even yielding corn as possible, even moisture corn as possible. We want small loads, all right? Probably 5 to 8,000 pound loads, all right? In a multi-point calibration, we're gonna do 4 to 6 loads, all right? And they're all need to be within a couple of % total weight of each other. So we can't have one 5,000 pound load, one 20,000 pound load. All right. So 5 to 8,000 pounds per load, 4 to 6 loads for any crop type that we're actually calibrating for. The reason we do this, the reason we do 5 to 8,000 pounds, which is very, very critical, because we're training that flow sensor, whether it's an optical sensor or a pressure sensor, we're training it. We're putting a certain amount of flow, the flow that it's going to see at 150 bushel, the flow that it's going to see at 100 bushel, the flow that it's going to see at 200 bushel. We're putting that amount of flow against that sensor. All right, it's reading that amount of flow, and then we're telling it how much corn actually passed through that system. All right. So it's imperative that the flow that we have against that sensor stays as consistent as possible. So we want a consistent yielding spot, 150 or 200 bushel, so the evenest part of the field you have. But if we go much over 5 to 8,000 pounds per load, there ends up being a lot more variance in the flow throughout that pass. If we're having to do multiple rounds to get our calibration load, the combine actually runs empty on the ends and then starts filling back up. The flow drops way off and then gradually builds back up. Every time we drive through a waterway or a dead spot or an area with 2 or 3 rows missing going into the head, the flow drops down below our intended rate and then comes back up. We end up with quite a high variance in the actual load itself, from the highest flow to the lowest flow. All right, the closer we can keep that variance, the smaller we can keep that variance, the closer we can keep the high and low flow for that load, the more accurate that calibration will be. All right, so when we set these speeds, 2, 3, 4 mile an hour, which we can show you how to do next, we want to keep it at 3 mile an hour. We want to be very, very consistent in that spot. All right. Keep it at 3 mile an hour. Don't touch it. Don't work it. We always recommend the guys do the lowest speeds first, because then they're not tempted to cheat. If you do the highest speeds first, then when you do your 2 mile an hour, it seems very, very slow. And guys tend to speed it up, and all of a sudden this 2 mile an hour ends up becoming 2.9, and we end up with a calibration point right here, which doesn't do us a whole lot of good. All right, so keep those speeds consistent all the way across the field. Pick the most consistent yielding spot, and keep those loads fairly light, 5 to 8,000 pounds. We want enough in there that we can actually get a good reading, have accurate data, but we don't want it too big that we have a whole bunch of variance in between those loads themselves.